Welcome to Kentik's video training series on alerting. My name is Daniel Kelly, and I will be guiding you through this section of the Kentik user interface. This video was made to direct users in creating a policy to detect TCP SYN flood attacks, including all of the associated settings needed to get a good result. Our agenda today is to cover the following items as it relates to TCP SYN flood attacks. What is a traffic-specific policy? Dataset tab settings, and intermediate level threshold settings. Kentik utilizes policy definitions that evaluate traffic by type, unlike other systems which use a common notation, objects. Objects are often used in other systems to define networks or customers. Kentik offers a much more flexible policy definition which uses traffic type filters and can evaluate many or all of the objects used in other systems, often in a single policy. The traffic type filters for the policy we're reviewing in this video today will lock the policy to viewing packets which utilize the TCP protocol. Additionally, we'll want to see that the TCP flag field has the value for the SYN flag set. Since SYN floods often have a low bit size per packet and high packet per second rate, we'll focus more on the packet rate as we craft our policy. Starting with the Dataset tab and the device selection, I'm going to select all routers for the device choice provided. For general policies, picking specific devices is often discouraged unless there is a very good reason for it. Instead, try to utilize things like sites, all routers or all hosts, and tags. If you were to add a new device to a site or tag that was already created, or simply add a new router, any policy referencing the site, tag, or all routers option would automatically begin evaluating flows from this new device as soon as it was added. This prevents you from having to manage each policy's choices over time as devices are added to Kentik. This is a very helpful strategy for long-term management of your policies. In this policy, we only need two dimensions: destination IP, which is the target under attack, and the TCP flag. Which will allow us to show which flag in combination with SYN flags were present during an attack. Our primary metric is going to be packets per second. SYN floods will show a larger increase in the number of packets per second than in the number of bits per second during this type of an attack. For additional information, I will include bits per second in the secondary metrics field, and for a later evaluation, I will also include unique source IPs. For our filter, we will use three terms: standard directional filter, a filter to lock the protocol to TCP, and a filter to set the T-flag's value, where SYN is set. This filter will include SYN packets and SYN ACK packets as well. Any packet where the SYN flag is set will be evaluated. If we were to include SYN with the isOnlySet filter evaluation, we would include SYN-only packets, excluding things like SYN ACK responses. For this demonstration, we've determined that a 60-second lookup is favorable, as SYN floods can come in fast bursts. Since we're looking at a large number of devices and a large dataset, I will choose 299 keys. And I will be leaving the auto calculation enabled for our minimum traffic threshold, as I want the policy to automatically exclude keys which are lower than the lowest configured threshold to keep potential alarm noise down. Right now, the auto calculation threshold shows 0 kilopackets per second because we have not yet defined our alarm thresholds. Based on previous research, we have arrived at a minor level traffic threshold of 100,000 packets per second. We'll continue to use the static-only evaluation. Visiting the activate conditions under the notification section, we need to remember our lookup time is 60 seconds. As a result, the setting for 5 times in 2 hours could equate to a flood lasting a continuous 5 minutes, or a series of fast 60-second or greater spikes occurring at least 5 times inside of a rolling 2-hour window. Lastly, for this level, we'll set an email notification to let us know that this policy level has become active. Setting an additional, or multiple, thresholds per policy should be done carefully. Best practices include using higher threshold values for your primary metric as you work up the severity levels, considering including additional evaluations such as secondary metrics in the evaluation of higher levels, and changing the number of condition true events required to trigger alarms at higher levels depending on alarm noise. From our prior research into our traffic, I have also noted that we were getting SYN packet spikes of up to 2 megapackets per second, but after 500,000 packets per second, the target host went offline. We want to start the alarm period for this threshold right before we lose hosts, so we'll set our threshold to 400,000 packets per second. Continue to utilize the static-only evaluation method. I'm also interested to make sure that this was a distributed flood at some level, so I'm including secondary metric unique source IPs, which I will set to 300. When utilizing multiple conditions at once, they are all joined together with a logical end. So for any given destination IP address, receiving over 400,000 packets per second, we must also have more than 300 unique sources speaking to it for it to qualify of this level of the alarm. For the higher threshold level, I'm going to set the frequency down to 4 times in 1 hour. Meaning that 4 60-second lookups, a minimum of 4 minutes sustained, or any 4 minutes in a 1-hour period, are required before we alarm. I'm also interested in making sure that my NOC has acknowledged this traffic before it leaves the active boards. I'm placing the acknowledgement required control on this threshold. What this means is that a NOC member must acknowledge and comment the alert before it will leave the active alert dashboard under alerting active. Lastly, we set our notification channel. I'm also interested in emailing the boss directly when this happens, so I'll add a different and additional notification channel to this policy at the major level. To get a quick review of the work done so far, go to the Show Summary button on the top right-hand side and check out a scrolling description of policy settings. Menu items are collapsible, allowing you to view each tab individually. Everything appears as I've intended to set it, and so we're going to save this policy and activate it. Silent mode in this case may not be important because we're not using baseline settings. Since all policy is evaluated statically at the moment we poll, silent mode can be left off and the policy can be put into an active status immediately. That concludes this video in the Getting Started with Alerting series. Stay tuned for more releases in this series, which will cover even more advanced policy settings. Thank you.